The question of whether humans and dinosaurs ever shared the same planet has captivated imaginations for generations. Fueled by Hollywood blockbusters, ancient artwork, and controversial archaeological discoveries, while the scientific consensus firmly establishes that non-avian dinosaurs went extinct approximately 66 million years before the first humans appeared, the story is far more nuanced and fascinating than a simple no might suggest. From childhood, we are drawn to dinosaurs as symbols of power, mystery, and the exotic prehistoric past. They represent a world utterly different from our own, yet one that existed on the same planet we call home. The idea that our ancestors might have encountered these magnificent creatures appeals to our sense of adventure and survival, tapping into primal fears and fascinations that have shaped human storytelling for millennia. This enduring fascination stems from deep-rooted human psychology and our relationship with the natural world. We've all seen the movies. Dinosaurs roaring, humans running, but is there any truth to the idea that we lived side by side with these prehistoric beasts? Today, we separate fact from fiction and explore the ancient clues that might just surprise you. This is I'll Tell You What Happened. To understand the relationship between humans and dinosaurs, we must first examine the vast temporal chasm that separates these two groups. Dinosaurs first emerged during the Triassic period, approximately 230 million years ago, when the Earth looked dramatically different from the world we know today. The supercontinent Pangaea was still largely intact, and the climate was generally warmer and more humid than today's conditions. These magnificent creatures dominated terrestrial ecosystems for an astounding 165 million years, evolving into an incredible diversity of forms, ranging from the massive, long-necked sauropods like Brontosaurus to the fearsome predators like Tyrannosaurus rex. During this vast span of time, dinosaurs witnessed and survived multiple mass extinction events, adapted to changing climates, and colonized virtually every terrestrial habitat on Earth. They evolved complex social behaviors, sophisticated reproductive strategies, and remarkable diversity in size, diet, and lifestyle. Some dinosaurs were no larger than moderns, while others reached lengths of over 100 feet and weights exceeding 70 tons. They occupied ecological niches as diverse as those filled by modern mammals, from tiny insectivores to massive herbivores that could strip entire forests bare. The Mesozoic era, often called the Age of Reptiles, was divided into three distinct periods: the Jurassic and the Cretaceous. Each period saw significant evolutionary developments and environmental changes that shaped dinosaur. The Triassic saw the first dinosaurs emerge alongside the first mammals, both small and relatively insignificant compared to the dominant archosaurs of the time. The Jurassic period witnessed the rise of the giant sauropods and the diversification of theropod predators, while the Cretaceous period saw the evolution of advanced dinosaur groups like the reign of non-avian dinosaurs came to an abrupt end at the Cretaceous-Paleogene boundary, roughly 66 million years ago, likely due to a combination of catastrophic events, including a massive asteroid impact and intense volcanic activity. This mass extinction event, known as the Kappa-G extinction, eliminated approximately 75% of all species on Earth, including all non-avian dinosaurs. The asteroid impact, which created the Chicxulub crater in what is now Mexico's Yucatan Peninsula, released energy equivalent to billions of nuclear bombs. The impact ejected massive amounts of debris into the atmosphere, blocking sunlight and causing global cooling. Simultaneously, the Deccan Traps in India were experiencing one of the largest volcanic eruptions in Earth's history, pumping greenhouse gases and toxic compounds into the atmosphere. This double catastrophe created environmental conditions that proved fatal to most large terrestrial animals, In stark contrast, modern humans didn't appear until approximately 300,000 years ago, during the Middle Pleistocene age. Even if we expand our definition to include all members of the genus Homo, the earliest human ancestors only date back about 2.8 million years. This means there's a staggering gap of over 63 million years between the extinction of the last Nonavian dinosaurs and the emergence of the first humans. The evolutionary lineage leading to humans began much earlier, with the first primates appearing around 55 million years ago, shortly after the extinction of Nonavian dinosaurs. However, these early primates were small, tree-dwelling creatures that bore little resemblance to modern humans. The evolutionary path from these early primates to modern humans involved numerous branching points and evolutionary innovations, including the development of bipedalism, enlarged brains, and complex tool use. To put this timeline into perspective, imagine compressing Earth's entire 4.6 billion year history into a single year. In this compressed timeline, dinosaurs would have lived from early December until December 26th, while humans wouldn't appear until the final few minutes before midnight on New Year's Eve. The gap between dinosaurs and humans represents nearly 2 full days in this compressed timeline, an eternity in geological terms. This temporal separation is not merely academic. It has profound implications for understanding the development of life on Earth. The extinction of Nonavian dinosaurs created ecological opportunities that allowed mammals to diversify and eventually give rise to the human lineage. Without this extinction event, mammals might have remained small, nocturnal creatures indefinitely, never developing the large body sizes and complex behaviors that characterize modern mammalian development. Despite the clear scientific evidence for this temporal separation, several controversial discoveries and claims have emerged over the decades, suggesting possible coexistence between humans and dinosaurs. These claims, while largely debunked by mainstream science, continue to generate discussion and debate in certain circles, particularly among young Earth creationists and alternative archaeology enthusiasts. The most famous of these controversial pieces of evidence are the ICA stones of Peru, discovered in the 1960s by Dr. Javier. These carved stones, numbering in the thousands, depict what appear to be humans interacting with dinosaurs in various ways, including riding them, hunting them, and performing surgery on them. The stones also show detailed anatomical knowledge of dinosaur species that weren't scientifically described until decades after the stones were supposedly found. The ICA stones gained international attention when they were featured in various books and documentaries about ancient mysteries. Proponents claim that the stones represented knowledge passed down from an ancient civilization that had actually encountered living dinosaurs. The level of detail in some of the carvings was indeed impressive, showing dinosaurs with anatomical features that seemed to match scientific reconstruction. However, extensive investigation has revealed that the ICA stones are almost certainly modern hoaxes. The carving techniques used are consistent with modern tools, particularly high-speed rotary tools that leave characteristic marks not found in genuine pre-Columbian artifacts. Several of the supposed discoverers have admitted to creating fake stones to sell to tourists and collectors, revealing the commercial motivation behind their creation. The anatomical details of the dinosaurs depicted on the stones match popular reconstructions from paleontology textbooks rather than what we now know about actual dinosaur anatomy. Many of the dinosaurs shown have anatomical errors that reflect outdated scientific understanding or artistic interpretations rather than actual observation of living animals. Furthermore, the stones show no signs of the patination or weathering that would be expected from genuinely ancient artifacts. Perhaps most tellingly, the ICA stones include depictions of dinosaur species that were not discovered or described until decades after the stones were supposedly found. This suggests that the creators of the stones were drawing from contemporary Paleontological knowledge rather than ancient observations. Another frequently cited piece of evidence is the Paluxy River trackways in Glen Rose, Texas. In the 1930s, local residents discovered what appeared to be human footprints alongside dinosaur tracks in the limestone riverbed. These discoveries were seized upon by young Earth creationists as evidence that humans and dinosaurs coexisted, supporting their belief in a much younger Earth. The Paluxy River site became a pilgrimage destination for creationists and generated considerable media attention. The tracks seemed to show clear human footprints with 5 toes and arched feet, apparently walking alongside or even inside dinosaur tracks. For decades, these tracks were presented as definitive proof of human-dinosaur coexistence. However, detailed scientific analysis of the Paluxy tracks has revealed several problems with the human interpretation. Many of the supposed human prints are actually poorly preserved dinosaur tracks, natural erosion patterns, or deliberate carvings made by locals during the Great Depression to sell to tourists. The economic hardship of the 1930s led some residents to create fake human tracks to attract visitors and generate income. The few tracks that do resemble human footprints are either too large to be from actual humans or show characteristics inconsistent with human locomotion. Human footprints have distinctive patterns of pressure distribution, toe placement, and heel-to-toe progression that are absent from the Paluxy tracks. Additionally, the geological layers containing these tracks date to approximately 113 million years ago, long before any mammals larger than a shrew existed on Earth. Modern re-examination of the site using advanced imaging techniques has revealed that many of the supposed human tracks are actually elongated dinosaur tracks, where the heel pad impression has been obscured by erosion or sediment infill. When viewed under different lighting conditions or with digital enhancement, the dinosaur characteristics become apparent. Some researchers have also pointed to various ancient artworks and mythological depictions that seem to resemble dinosaurs. Ancient Cambodian temples feature carvings that some interpret as, while Chinese dragon legends and Mesopotamian cylinder seals show creatures that bear superficial resemblances to various dinosaur species. Proponents of human-dinosaur coexistence argue that these depictions represent cultural memories of actual encounters with living dinosaurs. The most famous example is a carving at the Ta Prohm Temple in Cambodia, built in the late 12th century, which shows what some claim is a clear depiction of a The carving appears to show a quadrupedal animal with plates along its back, remarkably similar to artistic reconstructions of This has led some to suggest that stegosaurs survived into historical times in Southeast Asia. However, these interpretations are highly speculative and ignore more plausible explanations. The supposed stegosaur carving at Ta Prohm Temple is more likely a stylized rhinoceros, wild boar, or chameleon, all animals that would have been familiar to the temple's builders. The plates along the back could represent decorative elements, vegetation, or stylized anatomical features common in Khmer art. Art historians note that Khmer temple carvings often combined realistic and fantastical elements, and that the supposed stegosaur lacks many distinctive features that would be expected if it were based on actual observation of such an animal. The carving shows no clear spikes on the tail, no distinctive beak-like mouth, and proportions that don't match actual stegosaur anatomy. Similarly, dragon legends and mythological creatures can be explained through a combination of discoveries of large fossil bones, cultural transmission of stories, and the human tendency to create fantastic creatures by combining features of known animals. Ancient peoples certainly encountered dinosaur fossils, and these discoveries likely contributed to legends of dragons and other mythical beasts. However, finding fossil bones is very different from encountering living animals. The fossil record provides the most compelling evidence against human-dinosaur coexistence. Paleontologists have discovered and catalogued hundreds of thousands of dinosaur fossils from around the world, spanning the entire 165-million-year reign of these creatures. Similarly, the human fossil record, while much shorter, is well documented and thoroughly studied. The science of stratigraphy, which studies rock layers and their formation, provides a clear timeline of Earth's history. Rock layers are deposited in sequence, with older layers generally lying beneath younger ones. This principle, known as the law of superposition, allows scientists to determine the relative ages of fossils found in different layers. Dinosaur fossils are found exclusively in Mesozoic rock layers, which date from 250 to 66 million years ago. Human fossils and artifacts are found only in much younger rock layers, primarily from the Quaternary period. Between these layers lie tens of millions of years of rock formation representing the Paleogene and Neogene periods, during which mammals diversified and evolved but no dinosaurs existed. If humans and Nenevian dinosaurs had truly coexisted, we would expect to find evidence of this coexistence in the fossil record. We would expect to find human fossils in the same geological layers as dinosaur fossils, evidence of human tools or weapons alongside dinosaur remains, or signs of human predation or scavenging on dinosaur carcasses. We would also expect to find dinosaur fossils in the same layers as human fossils, or evidence of dinosaur predation on early humans. None of this evidence exists. Human fossils are found exclusively in geological layers that are millions of years younger than the youngest dinosaur fossils. The two groups occupy completely separate stratigraphic zones, with no overlap whatsoever. This separation is consistent across the globe, from North America to Asia to Africa, indicating that the temporal gap between dinosaurs and humans is a universal phenomenon rather than a regional quirk. The transition from the Mesozoic era to the Cenozoic era is marked by a clear boundary in the fossil record. Below this boundary, we find dinosaur fossils, marine reptiles, and primitive mammals. Above this boundary, we find the remains of modern mammalian groups, but no Nenevian dinosaurs. This boundary represents one of the most dramatic changes in Earth's history, marking the end of one evolutionary era and the beginning of another. Furthermore, the mammalian fossils found in dinosaur-bearing rock layers are exclusively small, primitive creatures that bear no resemblance to primates or any other group that could be ancestral to humans. During the Mesozoic era, mammals were small, nocturnal creatures that lived in the shadows of the dinosaurs, occupying ecological niches similar to modern shrews and rats. The largest mammals of the dinosaur age were no bigger than a modern badger, and none showed any of the characteristics that would later define the primate lineage. The early mammals of the Mesozoic were primarily insectivores, with some species adapting to aquatic or arboreal lifestyles. They had small brains, simple teeth, and basic sensory systems. The complex social behaviors, advanced cognition, and sophisticated tool use that characterized modern primates were still tens of millions of years in the future. Radiometric dating techniques provide additional confirmation of the temporal separation between dinosaurs and humans. These methods, which measure the decay of radioactive isotopes in rocks and fossils, allow scientists to determine absolute ages rather than just relative positions in the stratigraphic sequence. Radiometric dating consistently shows that the youngest dinosaur fossils are approximately 66 million years old, while the oldest human fossils are less than 7 million years old. The precision of modern radiometric dating techniques has improved dramatically over the past several decades, allowing scientists to date fossils with remarkable accuracy. Multiple independent dating methods, including uranium-lead dating, potassium-argon dating, and radiocarbon dating, all provide consistent results that support the standard geological. While non-avian dinosaurs and humans never coexisted, there is a remarkable twist to this story that brings dinosaurs into our modern world. Birds are dinosaurs. This isn't a metaphor or a loose comparison, but a scientific fact based on extensive anatomical, genetic, and fossil evidence. The evolutionary relationship between birds and dinosaurs was first proposed in the 19th century by Thomas Henry Huxley, who noticed striking similarities between the skeletons of birds and certain dinosaur species. Huxley observed that birds and dinosaurs shared numerous anatomical features, including similar pelvic structures, leg bones, and skull characteristics. However, this idea fell out of favor for much of the 20th century until a renaissance in dinosaur paleontology, beginning in the 1960s, brought new evidence to light. The revival of the dinosaur-bird connection began with the work of paleontologist John Ostrom, who studied the small predatory dinosaur Deinonychus in the 1960s. Ostrom's detailed analysis revealed that Deinonychus was an active, agile predator with many bird-like characteristics, challenging the prevailing view of dinosaurs as cold-blooded, sluggish reptiles. This work sparked a revolution in dinosaur paleontology that continues today. The discovery of feathered dinosaur fossils in China during the 1990s and 2000s provided definitive proof of the bird-dinosaur connection. Fossils like and Microraptor showed that many dinosaur species possessed feathers, and that the transition from dinosaur to bird was gradual rather than sudden. These discoveries revealed that feathers originally evolved, not for flight, but for insulation and display, with flight capability developing later. The Chinese feathered dinosaur discoveries were revolutionary because they preserved soft tissues that are normally lost during fossilization. The fine-grained sediments of the Liaoning province created ideal conditions for preserving feathers, skin, and other delicate structures. These fossils showed feathers in various stages of development, from simple filaments to complex flight feathers, providing a clear evolutionary sequence. Some of the most spectacular feathered dinosaur discoveries include Antio, a small dinosaur with 4 wings, and Borriella pelta, a heavily armored dinosaur that retained its original reddish-brown coloration. These fossils have allowed scientists to reconstruct not just the appearance of ancient dinosaurs, but also their behavior and ecology. Modern phylogenetic analysis, which examines evolutionary relationships based on shared characteristics, places birds firmly within the dinosaur family tree. Specifically, birds are theropod dinosaurs, belonging to the same group that includes famous predators like Tyrannosaurus rex, Velociraptor, and Allosaurus. In fact, birds are more closely related to these carnivorous dinosaurs than many dinosaur species were to each other. The evolutionary tree of dinosaurs reveals that birds are nested deep within the theropod dinosaur group. This means that calling birds dinosaurs is not an oversimplification or analogy, but a precise taxonomic classification. Just as humans are mammals, birds are dinosaurs. The distinction between birds and dinosaurs is largely a matter of convenience rather than evolutionary reality. This means that every time we see a bird, we are literally looking at a living dinosaur. The chicken pecking in a farmyard is a direct descendant of the mighty theropods that once terrorized the Mesozoic landscape. The hummingbird hovering at a flower feeder shares a common ancestor with Tyrannosaurus rex. The eagle soaring overhead carries within its genes the legacy of 230 million years of dinosaur evolution. This evolutionary connection helps explain many aspects of bird behavior and anatomy that might otherwise seem puzzling. The aggressive territorial behavior of many bird species echoes the competitive nature of their dinosaur ancestors. The elaborate courtship displays of birds like peacocks and birds mirror the display behaviors that we now know were common among dinosaurs. Even the way birds move, with their distinctive head-bobbing gait, reflects their dinosaur heritage. Recent research has revealed that many behaviors once thought to be uniquely avian actually originated in non-avian dinosaurs. Nest building, for example, was practiced by many dinosaur species, as evidenced by fossil nests and eggs found around the world. Some dinosaurs even sat on their nests to incubate their eggs, just like modern birds. The study of modern birds has also provided valuable insights into dinosaur biology and behavior. By observing how birds build nests, care for their young, and interact socially, paleontologists can make informed inferences about the behavior of extinct dinosaur species. The discovery that many dinosaur species were likely warm-blooded, for example, was supported in part by comparisons with modern birds. Bird respiration, which involves a complex system of air sacs and one-way airflow through the lungs, is now known to have evolved in dinosaurs. This efficient respiratory system may have been one of the key innovations that allowed dinosaurs to become so successful and diverse. The presence of air sacs in dinosaur bones, evidenced by pneumatic openings and hollow structures, shows that this advanced respiratory system was already present in many dinosaur lineages. The idea of humans and dinosaurs coexisting has been powerfully reinforced by popular culture, particularly through movies, television shows, and literature. The 1993 film Jurassic Park and its sequels have been particularly influential in shaping public perception. Despite their scientific inaccuracies, these films present a world where dinosaurs and humans interact directly, creating thrilling scenarios of predation, escape, and survival. While Jurassic Park does acknowledge that dinosaurs are extinct and must be brought back through genetic engineering, many other works of fiction simply ignore the temporal gap entirely. The classic 1966 film 1,000,000 Years BC famously depicts caveman battling dinosaurs, while animated series like The Flintstones present a whimsical world where humans and dinosaurs live together in a Stone Age society. With modern conveniences, these fictional portrayals have had a profound impact on public understanding of prehistoric life. Many people's first exposure to dinosaurs comes through popular media rather than scientific education, creating lasting impressions that can be difficult to correct. The dramatic, action-packed scenarios depicted in movies and television shows are far more memorable than the dry recitation of geological timescales and fossil evidence. The entertainment industry has also contributed to widespread misconceptions about dinosaur appearance and behavior. Many popular depictions showed dinosaurs as oversized, savage monsters rather than the diverse, complex animals they actually were. The tendency to portray all dinosaurs as dangerous predators ignores the fact that the majority of dinosaur species were, and many were quite small and peaceful. These fictional portrayals tap into something deep in the human psyche. There's something inherently appealing about the idea of our ancestors facing off against these magnificent and terrifying creatures. It represents the ultimate test of human ingenuity and survival skills, pitting our intelligence and tool-making abilities against raw prehistoric power. The persistence of these myths in popular culture also reflects our fascination with the prehistoric world and our desire to feel connected to Earth's ancient past. Dinosaurs represent a time when the world was fundamentally different, when giant reptiles ruled the land, and the very landscape bore little resemblance to the world we know today. By imagining ourselves in that world, we can vicariously experience the thrill of living in a truly wild and untamed environment. However, this romanticized view of human-dinosaur interaction often ignores the harsh realities of what such coexistence would actually entail. If humans had truly lived alongside large predatory dinosaurs, our species would likely have remained small, scattered populations living in constant fear of predation. The development of agriculture, civilization, and technology would have been virtually impossible under such circumstances. The psychological appeal of dinosaurs extends beyond simple fascination with large, dangerous animals. Dinosaurs represent the ultimate expression of biological success and diversity. They've dominated terrestrial ecosystems for over 160 million years, developing an incredible array of forms and lifestyles. This evolutionary success story resonates with humans, who have achieved their own form of dominance through intelligence and technology rather than physical prowess. Understanding why dinosaurs went extinct while mammals survived provides important insights into the nature of mass extinction events and evolutionary adaptation. The Kappa-G extinction event that ended the age of dinosaurs was one of the most severe mass extinctions in Earth's history, but it wasn't random in its effects. The asteroid impact that likely triggered the extinction created a global catastrophe that fundamentally altered Earth's climate and ecosystems. The impact threw massive amounts of debris into the atmosphere, blocking sunlight and causing global cooling. This led to the collapse of photosynthesis-based food chains, starting with plants and working its way up through herbivorous dinosaurs to the carnivores that depended on them. The immediate effects of the impact were catastrophic. The energy released by the 10-kilometer-wide asteroid was equivalent to billions of nuclear bombs, creating a fireball that extended halfway around the globe. The impact generated massive tsunamis, earthquakes, and volcanic activity. Within hours, the entire planet was shrouded in darkness as debris and soot blocked out the sun. The longer-term effects were equally devastating. The nuclear winter conditions persisted for months or even years, causing global temperatures to plummet and bringing photosynthesis to a virtual standstill. Plants died, herbivores starved, and carnivores followed suit. The food webs that had supported dinosaurs for over 160 million years collapsed within a geological instant. However, not all life forms were equally vulnerable to these changes. Small mammals, which were already adapted to nocturnal lifestyles and omnivorous diets, were better positioned to survive the post-impact world. Their small size meant they required fewer resources, and their varied diets allowed them to take advantage of whatever food sources remained available. Many mammals were also already adapted to cooler temperatures. Due to their fur and higher metabolic rates, the survival advantages of mammals extended beyond their physical characteristics. Many mammalian species were already adapted to living in underground burrows, which provided protection from the initial impact effects and the harsh surface conditions that followed. Their ability to enter torpor or hibernation allowed them to survive extended periods of food scarcity. Birds, as dinosaurs themselves, represent an interesting case study in survival. The bird lineages that survived the Kappa-G extinction were generally smaller, more adaptable species that could exploit a variety of food sources. The large, flightless birds that existed during the early Paleocene epoch suggest that the ecological niches left vacant by non-avian dinosaurs were quickly filled by their surviving relatives. The survival of mammals and birds, while the extinction of non-avian dinosaurs set the stage for the evolutionary radiation that would eventually lead to the emergence of humans. Without the Kappa-G extinction event, mammals might have remained small, nocturnal creatures indefinitely, never developing the large body sizes and complex behaviors that characterize modern mammalian. The extinction selectivity of the Kappa-G event provides important insights into the factors that determine survival during mass extinctions. Body size was a crucial factor, with animals weighing more than 25 kilograms having little chance of survival. Dietary flexibility was also important, as specialist feeders were more vulnerable than generalists. Geographic distribution played a role as well. with species that had wider distributions being more likely to survive than those with restricted ranges. The temporal separation between dinosaurs and humans illustrates one of the most challenging concepts in science: deep time. The human mind is not well equipped to comprehend the vast scales of geological time, and this cognitive limitation contributes to misconceptions about when different life forms existed on Earth. For most of human history, people had no concept of deep time. The age of the Earth was thought to be measured in thousands of years, not billions. Religious and philosophical traditions generally assumed that the world had been created in essentially its current form, with little change over time. It wasn't until the development of modern geology and radiometric dating techniques that scientists began to appreciate the true antiquity of our planet and the life forms that have inhabited it. The concept of deep time is fundamentally alien to human experience. Our species has existed for only a tiny fraction of Earth's history, and recorded human history spans only a few thousand years. We have no direct experience of the vast timescales involved in geological and evolutionary processes, making it difficult to comprehend the true scale of Earth's history. This difficulty in comprehending deep time has practical implications for science, education, and public understanding of when people hear that dinosaurs lived millions of years ago, and humans evolved millions of years ago, they may unconsciously compress these timescales and assume the two groups were Effective science communication must find ways to make these vast timescales more comprehensible and meaningful to general audiences. Educational approaches that use analogies and visual representations can help make deep time more accessible. Comparing Earth's history to more familiar, such as a 24-hour day or a calendar year, can help people appreciate the relative duration of different geological periods. Interactive exhibits and multimedia presentations can also help convey the vastness of geological time in ways that traditional textbooks cannot. The study of dinosaurs and human evolution also highlights the dynamic nature of life on Earth. Species come and go, ecosystems rise and fall, and the planet itself undergoes constant change over geological timescales. Understanding this deep history provides important context for current environmental challenges and helps us appreciate both the resilience and fragility of life on Earth. While the basic timeline separating dinosaurs and humans, as well as paleontological research, continues to refine our understanding of both groups, new dinosaur species are discovered regularly, adding to our knowledge of dinosaur diversity and evolution. Recent discoveries have revealed dinosaurs with elaborate feather displays, evidence of complex social behaviors, and sophisticated parental care strategies. The pace of dinosaur discovery has accelerated dramatically in recent decades. New species are being described at a rate of approximately one per week, with many of these discoveries coming from previously unexplored regions of the world. Countries like China, Argentina, and Madagascar have become major sources of new dinosaur fossils, each contributing unique insights into dinosaur evolution. Modern paleontological techniques have revolutionized our understanding of dinosaur biology. Advanced imaging techniques like CT scanning and synchrotron radiation allow scientists to examine the internal structure of fossils without damaging them. These methods have revealed details about dinosaur brain structure, respiratory systems, and even the contents of fossilized stomachs. Chemical analysis of dinosaur fossils has provided unprecedented insights into their physiology and behavior. Isotope analysis of dinosaur bones can reveal information about their diet, migration patterns, and metabolic rates. The discovery of preserved proteins and other biomolecules in some dinosaur fossils has opened new avenues for understanding their evolutionary relationships and biology. Similarly, research into human evolution continues to push back the timeline of our species, development and reveal new details about our evolutionary history. The discovery of new hominin species like Homo naledi and Denisovans has complicated our understanding of human evolution, revealing that our family tree is more complex and bushy than previously thought. The application of genetic techniques to ancient DNA has revolutionized our understanding of human evolution and migration. By analyzing DNA from ancient bones and teeth, scientists can trace the movements of early human populations and understand how different groups interacted and interbred. This research has revealed that modern humans carry genetic material from several extinct hominin species, including Neanderthals and Denisovans. One area of particular interest is the study of the mammals that lived during the age of dinosaurs. While these creatures were generally small and unremarkable compared to their giant reptilian contemporaries, they represent the evolutionary foundation from which all modern mammals, including humans, would eventually arise. Understanding these early mammals helps scientists trace the evolutionary path that led from small, shrew-like creatures to the diverse array of mammalian life forms we see today. Recent discoveries have revealed that Mesozoic mammals were more diverse than previously thought. Some species adapted to aquatic lifestyles, others became gliders, and a few even developed the ability to feed on baby dinosaurs. These discoveries show that mammals were already experimenting with many of the ecological niches they would later dominate after the extinction of non-avian dinosaurs. The development of new analytical techniques is also providing fresh insights into the biology and behavior of extinct species. CT scanning of fossils reveals internal structures that were previously inaccessible, while chemical analysis of fossilized tissues can provide information about diet, metabolism, and even coloration. These techniques are helping to paint an increasingly detailed picture of what life was like during the age of dinosaurs. The story of dinosaurs and humans is ultimately part of the much larger story of life on Earth. Over the past 3.8 billion years, our planet has been home to an incredible diversity of life forms. From the earliest single-celled organisms to the complex ecosystems we see today, each major group of organisms has had its time of dominance, only to be replaced by new forms, better adapted to changing conditions. Before dinosaurs ruled the Earth, other groups held sway. The Permian period saw the dominance of mammal-like reptiles called therapsids, some of which grew to enormous sizes and developed complex social behaviors. Before that, amphibians ruled the swamps and forests of the Carboniferous period, while primitive fish dominated the oceans of the Devonian period. The age of dinosaurs represents just one chapter in this vast story, albeit a particularly spectacular one. Before dinosaurs, the Earth was dominated by different groups of reptiles, amphibians, and earlier life forms. The Triassic period saw fierce competition between different groups of with dinosaurs eventually emerging as the dominant terrestrial After the extinction of non-avian dinosaurs, mammals rose to eventually giving rise to the diverse array of mammalian life we see today, including our own species. The Cenozoic era, often called the Age of Mammals, has seen the evolution of whales, elephants, primates, and countless other mammalian groups, each adapting to fill different ecological niches. This perspective helps put the human-dinosaur timeline into proper context. Rather than seeing the separation between these groups as a missed opportunity for dramatic encounters, we can appreciate it as part of the natural progression of life on Earth. Each group had its time to flourish and evolve, contributing to the rich tapestry of life that has characterized our planet's history. The fact that humans never encountered non-avian dinosaurs doesn't diminish the significance of either group. Dinosaurs were remarkable creatures that dominated terrestrial ecosystems for over 160 million years, evolving into forms that ranged from tiny, bird-like creatures to massive, long-necked giants. Their success was built on a combination of evolutionary innovations, including efficient respiratory systems, diverse reproductive strategies, and remarkable adaptability to changing environmental conditions. Humans, despite our relatively recent appearance, have had an unprecedented impact on the planet, developing technology, culture, and civilization in ways that no previous species has achieved. Our species has become a geological force, capable of altering the planet's climate, ecosystems, and even the course of evolution itself. This impact, both positive and negative, represents a new chapter in the story of life on Earth. The study of extinct organisms like dinosaurs provides important lessons for understanding current environmental challenges. The fossil record shows that mass extinctions have occurred repeatedly throughout Earth's history, each time dramatically altering the course of evolution. Understanding these past events can help us better prepare for and potentially prevent future extinctions. The question of whether humans and dinosaurs ever coexisted has a clear scientific answer. No, they did not. The fossil record, geological evidence, and our understanding of evolutionary timescales all confirm that Nanavian dinosaurs went extinct approximately 66 million years before the first humans appeared on Earth. The controversial claims and supposed evidence for coexistence have been thoroughly debunked by scientific investigation, revealing them to be hoaxes. Misinterpret. The next time you hear a bird chirp, remember, you're hearing an echo from the age of dinosaurs. If you learned something new today, spread those wings and hit that subscribe button, because I'll tell you what happened is just getting started.